Welcome to Geometric Series Formula. So the first question is, what is a geometric series in the first place? Because right now we've only dealt with sequences. So a sequence right now, is a list of terms such as 2, 4, 8, 16, and so on. Right now my common ratio is 2 because I'm multiplying by 2 each time. Now, when you add all these terms together, so if we get rid of the commas and add plus signs between all of the terms, now that becomes a series. So a sequence is just a list of numbers, but a series is when you add all of the numbers together. And think about it, right now, I can easily see that my sum here is, 30? However, when you have a long list of terms, it kind of becomes hard and tedious to find the sum of all of them. So in that case, we actually have a formula to help us do it. So as a recap, a sequence is a list of terms, but when we add those terms together, we get what is known as a series. So we do have a formula for it. And notice how it's a formula to find the sum of a finite geometric series. What that means is that we have a certain amount of terms that we are adding together. We're adding together the first 7 or the first 12 or the first 100. We're not adding together all of the terms in the sequence, right? Because that can really go on to infinity because there's always another term that you can find. And also because it says series, we should be keeping in mind we're finding the sum. The nice thing about this is that you don't have to remember the formula. It's on the reference sheet. And it's actually pretty simple to use. So S sub n stands for the sum of the first n terms. N is the number of terms that you're trying to find the sum of. A sub 1 is your first term. And R is your common ratio. Most of these we already know to begin with. Keep in mind that R cannot be equal to 1 because if you have a common ratio of 1, then you get 1 minus 1, which is 0, and that makes it undefined. Besides, if you ever have a common ratio of 1, it's super easy to find the sum of the series, right? Let's say if you had 7. The next term would be 7 and 7 because everything times 1 is just itself. And if you wanted to find the sum of that, you can just do, well, the sum of the first 4 terms would just be 7 times 4, which is 28. You don't really need a formula to figure that out. So we're not going to really deal with that. This formula is only good if you have a different common ratio. Let's try using the formula. So if you want to find the sum of the geometric series, we know it's a series because of the plus signs, you can just use your calculator. And if you were to plug that in your calculator, you should be getting 381. If you wanted to do it using the formula, we're going to know that our first term in this series, would be 3. Your common ratio, if you notice, you are multiplying by 2 each time. In order to find n, you have to count how many terms you're adding together. There are 7 terms, so n is 7, and S sub n is what we're trying to find. So the sum of the first 7 terms is a sub 1, which is 3 minus 3, R is 2, n is 7, over 1 minus 2. Please put that in your calculator using alpha y equals exactly as you see here. If there's parentheses, please use parentheses instead of using the multiplication sign. Writing it this way for a reason. It'll always be correct this way. If you're putting that in the calculator, No surprise, you should get 381 because that's what we got when we added it by hand. Let's try another example. If you want to find the sum of the first 25 terms, it is way easier to use this formula than to actually go and first find all 25 terms and then add them all together, because the numbers get pretty large fairly fast because we're talking about geometric sequences. Well, geometric series, but in a geometric sequence, they're modeled by exponential functions. So exponential functions get very large, very fast, and now you're adding all those large numbers together. Much easier to use the formula. Our first term is 3. Our common ratio is 2. This time we're finding the sum of the first 25 terms, and that's what we don't know. So the sum of the first 25 terms is equal to 3 minus 3 times 2 to the 25th power over 1 minus 2. Now I'll put that in your calculator and see what you're going to get. You should be getting 100,663,293. I told you that these get fairly large fairly quick. Way easier than actually adding when the numbers are that large. Also, keep in mind that if you have a negative first term, you're going to want to use parentheses around that in your calculator. Anytime you have a negative term or inputting a negative value into a formula, always put parentheses around it to be safe. Okay, last example, we're going to find the sum of a geometric series with 8 terms, whose first term is 3 and whose common ratio is 4. So we have, first of all, that they're talking about 8 terms. That means that's going to be n. The first term is 3, so that's a sub 1. And the common ratio r is 4. We're trying to find the sum of this using this formula that, again, is on your reference sheet. You don't have to remember it. So the sum of the first 8 terms is equal to 3 minus 3 times 4 to the 8th power over 1 minus 4. Try putting that in your calculator. And if you put that in the calculator, you should be getting 65,535. So just keep in mind that anytime you see series, well, geometric series, we're going to be using this formula, which is on your reference sheet. You know it's a series if you see plus signs instead of commas, which would mean it would be a sequence instead. Now, this formula only works for geometric series. We're not going to be studying arithmetic series in this course, so don't really worry about that just yet. And that's all for this video.